Hello everyone, and welcome to Linux Forensics here at Pentester Academy. In this video, we're going to talk a little bit about inodes and extended attributes. I know it's been a long journey. We've been talking an awful lot about inodes because inodes are just a wealth of information. So we're nearing the end at our investigation of the almighty inode. And today I wanted to tell you a little bit about extended attributes. Now, these are things that can be stored in the extra space between inodes. Recall that with ext4, typically on disk, an inode is 256 bytes. However, the current inode size is 156 bytes. So that gives you an extra 100 bytes. You can also store these extended attributes inside of a regular data block. You just have to point an element in the inode called file ACL to the data block. Why is it called that? The reason it's called that is the first use of extended attributes was in fact for ACLs, access control lists. However, you need to realize you can use this to store almost anything as a user attribute as long as the name starts with user period. You are fine. You can store all kinds of stuff. So some of you might be familiar with Windows alternate data streams, and this is a way that you can hide information inside of a Windows file. So you can do something very similar here in Linux with an extended attribute. We'll show you how to do this in a little bit. So if ACLs are used, the file system has to be mounted with the correct options if you have older kernels. If you have an updated kernel, this is no longer an issue. So it's just something to keep in mind. Probably won't come up for most of you, but it is a possibility. So if you're having some issues and you're running something that's not one of the latest kernels, you might want to look into that. What do these structures look like that are used to store extended attributes? Well, they start out with a header. Now, depending on whether or not this header is stored in an inode or in a data block, it looks different. So here at the top, I have what it looks like if you are storing it in just an inode. You have nothing but the magic number that's 4 bytes long. If it's in a data block, you have the magic number, a reference count, and the blocks used to store the extended attributes, a hash value, a checksum, and then there is some reserved space, 12 bytes of it. Following that, we have our actual entries. So they start out with a name length and then a name index. So what's this name index all about? This name index says, do I have a prefix? It would be extremely inefficient if I had common prefixes stored in ASCII or Unicode inside of every single one of these, especially given that I only have 100 bytes if I'm going to do it inside of the inode itself. 0 means there is no prefix. That user prefix that I mentioned earlier is 1. 2 means that you're using a ACL access list. 3 is another ACL access, in this case ACL default. 4 trusted, 6 security, 7 system, and 8 system rich ACL, which is not commonly used, but depending on the system it might be used. Then we have the offset from the first inode entry or the start of this block. Then we have the disk block where our value is stored, or 0 if it's in this block. The length of the value, and a hash for the attributes in block, or 0 if it's in the inode. The attribute name without a trailing null comes next. And that's pretty much it. So let's have a look at our extended attributes. So how can I look at these? It's pretty simple. There's a command get fattr, and I can run it on a particular file. I can run it on all files. And if I run it in this directory, you see that I have nothing. As you might expect, there is a set file, set fattr, and I can go ahead and set this on a particular file. Let's just set it on this one. Now, if I just hit enter, it's going to say, hey, you didn't give me any information. And it will give me a usage, like most well-behaved Linux commands. So I'll go ahead and say, oh, well, let me do this correctly. I want to give it a name, and my name will be user. Again, remember, I can get away with most anything that starts with user. And I'm going to say secret. And -v, a value. My value will be Mr. Roboto. That's my secret. I'm Mr. Roboto. Now, sure enough, if I run get fattr, once again, it shows up and it says, hey, look, you have an extended attribute on this file, but I want to see what it is. If I run get fattr, again, without any options or path, it says, well, what did you want to get? I want to do get fattr -n, and the name I want is user secret, and I'll just run that on all of my files. And it tells me for most of them, sorry, they don't have this attribute, but sure enough, for this file, it says it has the attribute and it's set to Mr. Roboto. So this is another way that someone could hide some data on you. Similarly, there are get facl commands and set facl commands. So I can go ahead and say, tell me about that same file, and it tells me about it itself, and it says, here's the file, here's who owns it, and it's got the standard permissions, nothing special. I can call set facl as well. I won't actually do that here. That is something that you can do, by the way, in any Linux system that supports this. You know, perhaps you want to set some permissions for a certain user and you don't want to mess with the normal file modes. It's just a one-off kind of thing. You don't want to add someone to a group or anything like that. And this is something that you can do with access control lists. Well, that's all for this video. As always, if you're enjoying these videos here at Pentester Academy, please tell a friend. We'll see you soon.